Hello, my name is Varun Rathore and I'm a data engineer. Today I'll be presenting a project of data pipeline for agriculture processing. Using pipeline, I'll convert the data from raw CSV into the relevant KPIs, which will be used by the government agencies or any of the business analysts working for the agriculture companies for the decision making when they sell their projects into the Indian market, or they have to present a report to the Ministry of Agriculture. So let's see. We have a project objective of automating the data processing through the pipeline. So we'll be using S3 and the Snowflake for data processing, and we have created a dimensional data model for analysis and reporting. Our task is to enable real-time data ingestion and also track the relevant historical track records of the data to further ingest the data with time. So I'll be using Kaggle for my data source, and the dataset I'm using was uploaded by Mr. Ajay Singh, who is in Punjab University. So my dataset look like this. We have many columns like state, district, crop, year, season, area, units of the area in hectares, production, and units of the production in tons, and yield. Let's move forward to the architecture. I'll be using Python to upload the CSV from my local directory into my S3 bucket, and from that S3 bucket I'll be using pipe to get the data out of the S3 bucket and put it inside my relevant stage table. So I've already created event notification in bucket, so that whenever the new CSV gets added into the bucket, the event is triggered and relevant data is ingested by pipe into my table. Let's see. This is my event notification I've created on the pipe. So this is my data set of S3. I had uploaded it using VS Code and the Python. I've used Boto3 library and OS library in Panda. So OS will be used to access the file from my local directory, and Boto3 will be used to upload the file into the S3, and Pandas will be used for the data processing of the file, so that the relevant format is applied on the file, and the file is uploaded using the Boto3 on S3. So a file got uploaded December 7. Let's move forward. So I have uploaded the file. Now I will show you the pipe and the external stage from which I have been uploading the file into the table. So yeah, I have created integration object and did the description of integration object to get the external ID that I have been pasting in the Snowflake role I have created. This is my external ID which I got. I pasted it here, and the errand which I got from the Snowflake description command. After that, I have been creating a file format for the CSV files, in which I have skipped the header, so that because whenever I will create a stage table, the headers will be automatically included, so I don't want them to get repeated. Trim space has been used to cut over the white spaces to avoid the errors. So then I have created external stage. External CSV stage is the name. I put the URL of my bucket folder in my bucket and the file format which I created here, and mention the name of the integration object. Then I created a table in which state is given as string, district is given as string, crop as string, and relevant data type given to all the columns. So I have created also an empty column which usage will be shown in future. So I got a year. I am storing this year as string. In further, I have created a fin year column, financial year, and I will be cropping out slicing the string and putting these year relevant data into that fin year column by and saving it as data type int. So let's move forward. We have created a stream called agree stream on table staging table, so that I can capture the relevant DML operations happening in the future on the stream. So till now we have been here. So I have created also a stream. So now I will run the pipe and show you how the agree table looks. I already ran all these commands, and now I'll directly show you how the agree table data looks like. So yeah, my agree table looks like this. We have state, district, crop, year, just like CSV. Now let's move forward. We have a stream. We have seen stream will capture the data one time, and once I consume the stream, the data will be gone. So I've already consumed the stream in a staging table here. So I will show you the staging table, which I named as temporary agree stage stream, which is consuming data from the stream. So yeah, the data is same columns, same data types, everything same, because it is the first time I've been consuming this. So all of the data looks like this in this staging table. Now I've been creating a schema called dimensions, in which I will store the dimensions and the fact table. So I've been creating a task to create the tables. So I've divided the data of the CSV into multiple dimensional tables for my star schema. So data will look like this. I have a big CSV which I have divided into state dimension. I have made a state ID, which is my primary key, which I have done through auto incrementing here. So from 1 to multiple, the numbers will be assigned to relevant state name. Similarly, I have created district dimension and created state ID in it, so that it can serve as my foreign key. I have created season dimension like this, crop dimension, year dimension. In future, I will be making fact dimension and using these state IDs, fact IDs and other IDs from the dimension table. So I have created a task. I have executed that task. I have already done that, and my data is populated. After that, I will be using another task to populate this table from my intermediate table, which is having my stream capture data. So I've already ran that task of populating. So I have multiple dimension tables, so all are filled with relevant data. Now I'll make an empty table called the fact table. Here it will containing fact ID, state ID, district ID, crop ID, state ID. All the IDs will serve as the foreign keys, and the particular numeric data like area, production unit, the data used for numeric purposes will be kept in that fact table and will be imported from the intermediate table itself. So I've already created that, and now I've created another task to fill that data. I'll be using merge into command to fill the data into the agriculture fact, so that the insert and update data gets filled into the fact table whenever my stream will capture new data, and stream table, the intermediate table will be filled with new data. So yeah, this is my merge command. I am selecting this column from the intermediate table, joining the other dimension tables in it. And whenever I got a matching column, then I will update the relevant data from the both tables, from the source table and from the intermediate table. Sorry. And if the data is not matched, then I will insert the data. So after that, I've already done that, so I will directly running the agree fact table to show you. Yeah, you can see we have yield everything and the year ID. So everything is stored in ID form, so that when I will run the KPIs, I can have a feature of fast processing. Only the numeric data is directly imported, just only IDs are imported. I can easily join that all the tables in it using these IDs as my foreign key. So one important feature is here that this KPIs runtime, which will be sorted because I am using IDs now to search the data and connecting all the tables with ID as my key, common keys. So we reached over here. We created multiple dimension tables by a task. We populated them using a task. We created a empty table of fact table and populated it with a task. Now we are left with KPIs. So yeah. So all of that things has been done in the Snowflake, but I have run through my Snowpark. So in my Snowpark, I've been using Snowpark library importing, and to get the credentials, I've been using a config file. I stored them in a dictionary form in a config file, and I've been importing that dictionary itself from my asset folder. Inside it, there is config.py file, and importing the dictionary remotely to get the credentials. Then I built a session here. I'm printing a message that Snowflake session is created successfully. I'll be running all those commands in here. I'll use session.sql and collect command to read the action and to give an action. After that, I've ran all the relevant commands in there only. One important feature is this time.sleep. So what happens is when I run the command, it happens in one go. So I need some time so that the tables get filled. Pipe also, I need some time to get filled. So I tracked all the time while running these queries in Snowflake and put relevant time, 1 or 2 seconds extra, so that all the tables get filled and all the dimension tables get filled to be so that I can fill my fact table from that dimension table. So yeah, all of these commands are working. So this is the output which I got. I created a Snowflake session. Stage table got created. Now I was waiting for 6 seconds. I got stream created. I got pipe created. Then I was waiting. Then I fetched rows from my staging table. Got rows. This many rows. Then I printed a message that my stage table is filled and stream has already recorded DMLs. Now I run a select star command on my intermediate table and it fetched these much rows. Now I printed a message that I already created it and it got the stream recordings too. Now the task will run, it will create and fill the table, and in the end it will print a message, process completed successfully. So I'll be now running the KPIs and move toward the KPI part. So yeah, data staging I have done. So I've been using incentive command to fill the dimension tables. Yeah, this logging dot sleep timer, which I told now, and in task I've been using the running every minute. So yeah, these are my results I showed you. KPI overview. So KPI, I have used the latest Indian Council of Agriculture research report. I've read the report and I searched for specific columns which I thought are relevant and are a point of concern for government and for businesses. So first is the yield efficiency by district. I've included both district and state, so that I can know that which district is in which state. If the person is from outside India, you can know. Seasonal production trends. In which season how much production happened in Kharif season, Rabi season, and all season which crop is there. The area utilization efficiency, I have again used both state and district columns. So it is taken from the chapter water and productivity, and page number I have listed here. So not specific productivity index is also there. I have also used only again used state and district both to showcase these. So yeah, I ran the queries, I got these results. Top 5 district with the highest yield efficiency. So I got Tirupattur district, Tenkasi district, Kozhikode, Mallapuram and Thiruvananthapuram. Let's run this query and see both the state and district name. So yeah, I've been doing limit 5 to watch only the top 5. So here is the district in Tirupattur in Tamil Nadu, yield efficiency is this much. So yeah, these are the data set projections which I got. So similarly, I have used other to in season whole year this much production is when seasonal production has been happening, and Kharif season this much production, and in winter season we got the lowest production. So let's move forward. I have state-wise area utilization efficiency. So Punjab has been highest state-wise utilization efficiency, and after that we got Maharashtra, Rajasthan, West Bengal, Haryana, Gujarat, Andhra Pradesh, Maharashtra, Madhya Pradesh, sorry. So district Eric candidate productivity. So Bijapur district has been highest productivity, and Karnataka has been a major player in this area, and all these majority states are from Karnataka only. Tamil Nadu is the second highest. Rest all the states are in descending form, in descending productivity, all the group by district name. So why this approach? I've used AWS and Snowflake. Why? Because it's scalable. So no matter how much data been added on in S3, the pipe will ingest it, and both of my platform, AWS and Snowflake, can handle it with time. The traffic and the space is no more concern for me now. So pipes and streams I've been using for real-time ingestion and historical tracking by streams of the staging tables, intermediate tables, and dimension tables. So automated dimension modeling has been doing. So the KPIs will be doing automatic dimension modeling because the relevant data will get updated with time. So insights from KPI. So I've been mentioning the main insights. So the yield efficiency. So main recommendations are providing better agriculture facility and sustainable irrigation facility, because the groundwater is also getting low in these areas, and fertilizers for relevant increase in those states having the lower productivity, We can use the fertilizers and also promote organic farming in the high fertilizer consuming areas where the productivity is high. If there is high fertilizer usage, so training to farmer in low efficiency, low districts, so that the efficiency get improved with time. So second is agricultural productivity. We have seen that Karnataka is the major producer. So to scale up the investments, so if there are majority districts in Karnataka which are low performing in other indexes, so to scale up and to double farmer income, which is also a target of government, we can market the arecanut of Karnataka, keeping it GI tag or something to export it and increase the farmer income from international market. If the productivity is too much, then domestic usage, domestic consumption will not be enough. We need international market too for those farmers. So yeah, we can market it outside. After that, there is seasonal insights. So we have seen that which season we get more productivity. So the recommendation is to allocate the labor, water, fertilizer strategically on the seasonal peaks to maximize our productivity, so that our prices can get low. And when our prices get low, then we can compete with international market, and our product will be sold more than the competitors. And yeah, the main target is to double the agriculture farmer income, the target which is being delayed time with time. So yeah, this can help the strategic decision making. It was only a sample. We can also add further insights in future. So concluding remarks are that yeah, we did it. We successfully created our pipeline and got somewhat meaningful insights for decision making. So yeah, in future scoping we can add more data like climate data to add to enhance our KPIs and add more KPIs. We can do anomaly detection in production trends and predictive modeling to forecast the crop yield, so that we can help the government to make decision making and help the companies to keep their prices targeted to keep their products of agriculture products at targeted marketing rates in future and in present. So yeah, that was all. Thank you and have a nice day.